This is the fifth video in a series of videos about graphing trigonometric functions. And in this video, I will focus on some examples of horizontal and vertical stretching, compressing, and shifting. Okay, I will draw very heavily from the content in video 4, where I introduced the ideas of horizontal, vertical stretching, compressing, and shifting. Okay, but I do want to review the very important rule of thumb that inside parentheses, it affects things that are horizontal, and it doesn't follow your intuition. It's opposite of what you first would think might happen. Things outside the parentheses affect the graph vertically, and it does follow your intuition. So I'm going to do a handful of problems, and hopefully by doing these problems, you'll get a sense of how to manipulate and to graph trigonometric functions that have been moved around the xy axis. So before we do that, I want to give you the general equations of sine, cosine, and tangent. Okay, I will start on the outside of the parentheses, which affects things vertically. Okay, and multiplying by a number right here will be a vertical stretch. Okay, which A will give you the amplitude, which I introduced in video 4, is the distance between the midline horizontally and the peak, or the distance between the midline and the bottoms of the troughs of the sine curves. Okay. B is a horizontal compressing or stretching. Okay. Now, B, very important, it gives you the period. Okay, so you should know that the period, T, is equal to 2 pi over B. That's a very important formula for us in working with the period. Okay, now C is a horizontal shift. Okay, and finally D is a vertical shift. Okay, and the exact same things happen with cosine. Okay, A is the amplitude, B is the horizontal compressing and stretching component, gives us the period. C still is the horizontal shift, and D is the vertical shift for cosine as well. And it also applies to tangent and cotangent and the other graphs, although questions that deal with amplitude and shifting and things tend to be focused on sine and cosine for some reason. Okay, so here's a handful of questions. We'll go through each one of these, and hopefully you'll get the sense of how to do them. In this first one, A, what is the period? Well, we get that from this 0.5. And the period is equal to 2 pi, that's the general period for the sine graph, divided by this number down here, right here, this 0.5. And that gives me, now 2 pi divided by half is 4 pi. Okay, and so the period of this graph is 4 pi. B, the amplitude is this number right here, 3. So the amplitude is 3. And C, how is this related to the parent function of sine of x? I'll just say verbally, in that it's been vertically stretched by a factor of 3, or has an amplitude of 3, and has been horizontally stretched by a factor of 2, and therefore has a period of 4 pi. Second one, what is the period of this function? Again, it's T is equal to 2 pi, because 2 pi is the general period of the cosine graph, divided by this number, 4, which simplifies to be pi halves. So every pi halves, this graph will begin to repeat itself. Okay. B is the amplitude, which is this number right here. A is -2, which does two things. First of all, it's been stretched by a factor of 2, and the negative makes it flip over the x-axis. Let me give you kind of a quick picture of what that looks like. Here's our graph, and our graph would look something, I mean, the general cosine looks like this. Okay? And it's been flipped over, so it's been flipped over like this. It'll be kind of also by a factor of 2. And it's a horrible graph, but that's the basic. It's been flipped over and been stretched by a factor of 2. Okay, C, as I just talked about those ideas, it's been flipped over, been stretched vertically by a factor of 2, giving us an amplitude of -2, and it's been compressed horizontally and now has a period of 2 pi. I'm sorry, pi halves. This graph, the period t is equal to 2 pi divided by the coefficient of x. Now, there's no number here, so I'm assuming it's 1. And it has the exact same period as the normal sine graph. Okay, this +2 right here will be a horizontal shift, but it will not affect the period. B, the amplitude is this number, 5, and so it's been stretched vertically by a factor of 5. And C, how's it related to the sine graph? Well, it's been shifted to the left 2 units and has been stretched vertically by a factor of 5, or has an amplitude of 5. Okay, let's just graph a couple of these. The way I will do these is by just drawing some dotted lines for each step, and then when I'm done, I will then draw a solid line to show my answer. Okay, and I tend to do things vertically first and then things horizontally. I'm not sure why that is. That's how I tend to do it. So the basic sine graph has an anchor point at 0, 0, okay, and has a period of 2 pi, okay, and so the graph will go, it'll first go up to 1, and then to pi, and then down. These are some good anchor points to kind of get an idea, and so the graph looks something like this. Okay, that's the graph. Okay, now the only change that's happened to this function is this plus pi halves. Now what that does, it's opposite of what you think, because it's inside parentheses and it's horizontal, and so it'll go this way, pi halves. So this point right here will be moved this way, pi halves, and be right here. This point will be moved this way, pi halves, and it'll be right here. This point is moved to the left, pi halves, and it'll be right there. This point is moved over here, and so the graph that I get will look like this. Make sure I draw it thick enough that I know what the answer is. Okay, so it's just been shifted over to the left, pi halves. Next, negative cosine of parenthesis x minus pi. Okay, now I'll first draw in what the cosine graph looks like. And it starts here, the anchor point is at 0, 1, and it will go down to pi halves, and then pi at pi. The cosine of pi is -1, and then back up to 1 at pi halves. So this is the cosine graph of the parent function. Okay, now I do things vertically first. So I'll first deal with this -1. The negative will flip it vertically. Okay, so now it'll be, this point will be down here. This point will stay at 0. This point right here will actually go up here. This point will stay, and this point will go down. And so it actually will look like this. Okay, now I don't really even need this one. If you want to erase it to kind of get rid of it, you can. Just going to delete that. Okay, so here's where I'm at currently. Next, I will deal with this minus x. Now, it's inside the parentheses, and so it's something that's horizontal, and it will not follow my intuition, so I need to go this way, pi units. So from this point, I will go over pi to right here. This point will go over here, pi to there. This point will go over here to pi and be there. And so basically, I'll start from this side now. It'll look like this. Okay, and that's our graph. Okay, now let's kind of flip this around a little bit. Now they're giving you're given the graph, and you're asked what is the equation of this sine graph. The fact they told us the sine graph is important because if it was cosine, we would create a different formula. Okay, now so my equation will be y equals something, possibly sine of something, and then something at the end. Okay, now the place that I start with this is vertically. So I look for the middle of the graph. The middle of the graph looks like it's right about here. and I kind of draw a dotted line, so I know where the middle of the graph is supposed to be. Okay? Now, the middle of the graph is a vertical shift. Okay? So being up 1 gives me a plus 1 at the very end of my graph. Okay? I next look at the amplitude. Now, this distance right here is 2, and that gives me my amplitude, which goes right here at 2. Okay? Now, I need to know exactly how this was shifted, or, well, let me look actually next at the period. Okay? The period from here to here, even though my graph is in whole numbers, not in terms of radians, in terms of pi, it still looks like going from 0 to 6 point something, that the period is still 2 pi. So there's been no horizontal compressing or stretching in this graph, and so it'll just be x. And then I need to see what kind of a shift there was. Now, keep in mind that sine has an anchor point of 0, 0, and then it starts going up. Okay, so the sine graph would start at 0, 0, and then start going up. And so that starting point looks like it's actually right here. Okay, where it's starting at the middle of the graph and starting to go up, and it goes up and then down and then back up. Okay, so it looks like it's been shifted this way, this distance. Okay, now although it looks like it's about negative 1.5 or x plus 1.5, my guess is, because we're dealing with trig functions, that this actually is pi halves, because pi halves is approximately 1.57-ish, I think. So it looks to me like it's been shifted to the left, pi halves, and so that is represented by x plus pi halves. So I know there's a lot of thinking that went into that problem, but this is the equation that would give me this graph. Okay, I first start vertically by looking at the middle of the graph, and that gives me this plus 1 at the end. I then looked at the amplitude and saw that it was 2, because that's the distance between the midline and the peak. Okay. I next looked at the period and noticed that from here to here, where it begins to repeat itself, it is still 2 pi, and so there's been no horizontal compressing or stretching. And then finally, I looked for a shift, and it had been shifted to the left pi halves, and so I did x plus pi halves, and that is how I figured out the equation for this graph. Okay, the next one is another one that's like this. What is the equation of this cosine graph? Again, the fact they told me that the parent function is really helpful. This is y equals something, possibly cosine of something. Okay, now I will do it in the exact same order as before. First, I'll look for the midline. Okay, it's going from positive 1 to negative 5, and the middle of that looks like it's about negative 2. Okay, now it's a vertical shift, and so this will be a minus 2 at the end. The next thing I look at is the amplitude. Now the difference between a peak and the midline is 3, and so that gives us the amplitude of 3. Okay. The next thing I'll look at is the period. So from peak to peak, this right here is 4. Okay, normally cosine has a period of 2 pi. Now this period of 4 means that there has been some kind of a horizontal compressing or stretching that has happened. Okay, now the formula t is equal to 2 pi over b is very useful for us, not only to find the period using b, but also using the period to find b. Okay, so I'm going to, I know the period is 4, I'll put that in for t, so 4 is equal to 2 pi over b. Now I can solve this equation for b. I'll just put this over 1 and then do a swapping. I can do it with proportions. And so b is equal to 2 pi over 4, which equals pi halves. So b must be pi halves. I'm actually going to move some of this stuff down because it's getting kind of confused, getting kind of mixed up with some of my other work. Okay, so I lost. This goes down here. Anyway, I'll just put that down there. B is pi halves. So what I get is I get pi halves, and then I might have x. I might have also a shift happening. So the next question I'd look at is a horizontal shift. Now, the cosine graph starts off at +1 and goes, we change colors here, it's getting a little confusing. +1 and goes down and then up and then down, right? And so where is that? Well, it looks like there's been no real shifting because it's starting at a peak and then going down. So no shift, horizontal shift, has happened in this graph. And so it looks like this is the graph that would give, sorry, the equation that would give me this graph. Again, I first do midpoint, and that gave me the -2. I then looked at the amplitude of 3, the difference between the midline and the peak. I then looked at the period and found the period was 4, which means that b would have to be pi halves, and there was no horizontal shifting that happened in this problem. Okay, next problem we'll look at is where they give us a description, and we have to, from the description, figure out what the equation would be. Number 1, write the equation of a graph of cotangent. Okay, so the parent function is cotangent with a period 2. Okay, now the period is 2, and the period is equal to, now one thing that we need to be aware of is that for the last problems we've always done 2 pi over b. Okay, and that works really well for sine, cosine. It even works well for secant and cosecant, but the cotangent graph actually has a period of pi. Okay, if you want to go back and look at video 2 where I graphed the cotangent, notice that every pi, it repeats itself. Okay, so instead of 2 pi here, I'll need to put pi, pi over b, okay, for cotangent. Okay, it's a little different than we've done in the past, but that's what we'll have to do. Okay, now the period is 2, and so 2 goes here, 2 equals pi over b. Put this over 1, I swap these, and so b is equal to pi halves. So that gives me a pi halves x that then shifted vertically down 4 units. Now a vertical shift is outside the parentheses, and down 4 means -4. Okay, nothing else is, there's no amplitude shift, and so this is the equation that is being described by number 1. Number 2, write the equation of the graph of cosine, that's our parent function, y equals cosine, with a period of pi. Okay, now we're back to cosine, and so the period again is 2 pi over b, and our period is pi. So t is pi is equal to 2 pi over b. Put this over 1. I switch diagonally, and b is equal to 2 pi over pi, and this cancels out, and b must be 2. So I get 2x, and that has been shifted vertically up 2 units. Now a vertical shift happens outside the parentheses. Up 2 units means it's +2, and has an amplitude, that's a, of 2/3. Now the amplitude is in front of the parent function, and so a 2/3 goes right here, and this is the equation that would be described by number 2. Okay, last one. Write the equation of a graph of sine with a period of 4 pi that has been shifted horizontally to the left 3 units and has an amplitude of 3 and has been flipped across the y-axis. Wow, a lot going on there. Okay, let's start off the very beginning. Sine. So y equals sine of stuff. And a period of 4 pi. So I know that with a sine, that t is equal to 2 pi over b. The period they've just told me is 4 pi. So that goes right here, 4 pi over 1. I will switch diagonally, and so b is equal to 2 pi over 4 pi. The pi's cancel, and I get 1/2. So b must be 1/2. So I get 1/2. And I want to put an x right here, but there's also been a horizontal shift. So that'll happen actually right here, another set of parentheses. And left 3 is this way 3, which actually is a plus 3. Okay, because things inside parentheses are opposite of what I think would happen, and has an amplitude of 3. Now, amplitudes happen in front of the parent function, 3, and has been flipped across the x-axis. Now, let's look at what that would look like. Here is a quick graph. Now, our basic sine graph looks like this. And shifted across the x-axis means flipped down here and flipped up there. And so it'll look more like this. And the way that happens is if the amplitude is negative. Okay? So it's a vertical change, and so that happens outside the parentheses by putting a negative 3 sine of 1/2 parenthesis x plus 3 close parentheses. Okay? And this is the equation. Okay, I know there's a lot going on in those questions. Okay, so there's a lot that's happening, to the amplitude, to the period, to shifting up and down and left and right. This is why these questions are so challenging for students in pre-calculus. If you are struggling with these ideas, you are by no means alone. With questions like this, okay? But I hope the rule of thumb as far as inside the parentheses is horizontal, outside the parentheses is vertical, will be very useful for you. If you have other questions, feel free to put a comment to the video, or anyway, hopefully these videos were helpful for you in figuring out how to graph trigonometric functions in pre-calculus. Thank you so much for watching.